Hello friends, welcome to Easy Learning with Arnav once again. And today we are back with a new topic of grade 8 NCERT syllabus, that is chemical effects of electric current. So, what do you think? What is an electricity? So, an electricity is a kind of energy that is formed by moving charges. These are the charges you can see. When these move, then they form a energy that is called electricity. So what do we call electricity? Okay. So metals are considered as a good conductor of electricity due to the flow of electric charges in them. So we are going to discuss what are conductors, but you must know that metals can conduct electricity. They allow flow of electric charges in them very well. So what is electric current? What are electric current? So electric current can be defined as flow of electrons. These are the electrons. When these electrons flow, they are called electric current, and they can produce three type of effects, that are chemical, heating and magnetic effects. So I hope you have studied magnetic effects in grade 7. So now we are going to discuss chemical and heating effects of electric current. Okay. Electric current cannot flow on the conductor on its own. An electric circuit, which is a closed loop path made up of electric components like wire, battery, switch, bulb, etc., is needed for current to flow in a wire or conductor. So electric current need a medium. They need a path to flow. They alone cannot flow. They need a path, and those paths are wire, battery, switch, bulb. They are called electric circuit. Okay, so the path for electric components or electrons to flow, electric current to flow, they are called electric circuit. Okay, so electric current is flow of electrons and electric circuit is a path of electrons to flow. Okay. Now conductors and insulators. Now, based on the conductivity, substances are divided into two parts. So conductivity means can they conduct electricity inside them or not. Okay. So first one is conductors. Conductors are the substances that allow electric current to pass through them. They allow the flow of electrons inside them. So most of the metals like gold, silver and copper etc. are some good example of good conductors. Okay. So metals almost all metals are good conductors of electricity. Now insulators. Insulators are just opposite of conductors. Insulators are the substances that do not allow an electric current to pass through them. Okay. So insulator can also be known as bad conductor. Now we will study what are good conductors and what are bad conductors. You can take so example of insulators are rubber, wood, plastic, glass, etc. They are bad conductor of electricity. Now the question raised is, can liquid conduct electricity? So yes, most liquid can conduct electricity because they have free electrons or ions that carry the electricity through the liquid. So you can take example of water. They have ions. They have free electrons. The electrons carry those electric components to the they create a circuit. They create the path for electric components. These ions can create path for electric components. So yes, liquid can also conduct electricity. Most liquids, and mostly acidic solution, acidic, basic and salty solution mostly are example of conductors, good conductors. These liquid that conduct electricity, they are called electrolytes. What they are called? Electrolytes. Okay, you can take an example of lemon juice, sodium hydroxide, and tap water. Tap water has some salts, impurities. That's why they carry electricity, they electric components. Milk is also a good example. Vinegar. Now, what is distilled water? Distilled water is a water that does not have free electrons or ions to move, so they cannot conduct electricity. See, here it is also written same, as it doesn't contain salts, hence distilled water is a bad conductor of electricity. Oil, petrol and kerosene are poor conductor of electricity, as they do not have free electrons or ions to conduct electricity. Now, now one question can come in your exam, that can milk also conduct electricity? Are they good conductor of electricity? So yes, they are also good conductor of electricity because they contain water and lactic acid. And I told you that mostly acidic solution are good conductors of electricity. So here lactic acid, so you can understand that it is a acidic solution. It also has acid. So I told you that acidic solution can conduct electricity. Now test for conductivity of liquid. So here is a diagram to show conductivity of a lemon juice. Now here there are some points written here. Firstly, take a liquid like lemon juice in a container. So they have taken lemon juice here for the conductivity test. When an electric current, wait, let me change something. Let me change its color. Yes. Now fine. Okay. So when an electric current passes through a conducting liquid, it gets decomposed into ions. Okay, so suppose here's a cell. This is a diagram of cell. It represents cell battery. Okay, so the electrons move from here to here like this. Okay, and now the lemon juice has some ions. They have free electrons to carry those electric components. Okay, they have ions that can carry electric components. Okay, so they carry and they connect this to the wire, and the electricity reaches the bulb. Okay, and the bulb glows. Okay, so it is a good conductor of electricity as it contains citrus acid having H plus ions, which are responsible for conduction. I told you again here, again this is a acidic solution, so it has citrus acid, and I told you acidic solution conduct electricity. So they are also a good conductor of electricity. They have ions. I told you when a liquid contains free electrons and ions, they are good conductor of electricity. Okay, if the electric bulb glows in this arrangement, this means our liquid is a good conductor of electricity. Here it's a spelling mistake, of electricity. It's of electricity. Okay, so see, lemon juice is also a good conductor of electricity, and the bulb has glown up. The more ions in liquid leads to a better conduction of electricity. So if there are more ions in a liquid, they can carry more electric components, and this will be an example of a better conduction of electricity. Okay, so I hope you understood this topic. Now, heating effects of electric current. So I told you in the starting of this chapter that electric current has some effects like heating effects, chemical effects and magnetic effects. Today we are going to study heating effects and chemical effects of electric current. Heat is produced when an electric current flows through a conductor. When these electrons flow uh, when the electrons flow, they heat up the circuit. Heat is produced when an electric current flows through a conductor. The conductor gets heat up because they flow. This is referred to as the heating effect of electric current. Okay. The glowing of the bulb is caused by heating effect of current flowing through it. Okay. So now we will study how the bulb glows. How the bulb glows. So it glows because of heating effect. Now we are going to study how heating helps the bulb glow. These are some labeling, that this is a glass bulb, this is glass filling, tungsten filament, support wires, lead wires, dumate wires, stem cap. So only two things are important: glass bulb and tungsten filament. Okay, because we are going to study only these two. So bulb is the body. Okay, this is the body, and a filament is a metal. It is a very thin wire. Okay, and it has a high melting point. It cannot melt easily. If this get heated up, then it will glow but not melt. And the best metal to make filament in bulbs, they are tungsten. It is a kind of metal that is used to make filament. They are very thin and has a high melting point. They cannot melt easily. See, if the electrons move, they create heating effect and it gets heated up. And I told you that they have a high melting point, so they will not melt, but still they will glow, and the bulb will also glow. Okay. To determine if a substance conducts or not by the heating effect, when current is passed through the bulb, the filament tungsten is the metal, heats up to high temperature, causing the bulb to glow. Okay. However, if the current is extremely small, see, electrons are already small, but if they are extremely small, the filament will not be heated to high temperature and thus will not glow, because they will not get heated up. And then what's the need of glowing? Now, LED bulbs are more suitable for testing the electrical conductivity of liquids. So now we use LED bulbs to test the electric conductivity of liquids. As the LED bulbs can detect the flow of even a small amount of electric current, so LED bulbs are very sensitive. They can even sense a small amount of electric current. So they are used for checking the conductivity of liquids. Okay, the electric current causes a heating effect due to which the filament of bulb gets heated up. It also has a filament. Okay, it has the same theory like the bulb, heated up and glows. Some liquids are capable of conducting electricity, but they are weak conductor of electricity, and the current that passes through them are not that strong enough to heat up the filament. But the use of LED bulbs overcomes this situation. Okay, so LED bulb, it is saying the same thing, that it will glow because of heat. If they will not glow, then that means they have a very weak electron. Okay, and they are actually very sensitive, so they can overcome this situation. Okay, now we are going to study chemical effects of electric current. Okay, the chemical effects of electric current can be defined as passage of an electric current through a conducting solution or an electrolyte that causes chemical changes. So basically it wants to say that if a electrolyte, I said that electrolyte is a liquid that can conduct electricity. That is a good conductor of electricity. They have free electrons or ions. Okay, so when electricity is passed through them, it splits up the atoms and ions inside the electrolyte. You can take example of water. I will tell you why, how they get split up. Okay, this is because of chemical reaction that takes place when an electric current passes through a solution. So it is saying that the chemical reaction takes place when electric current passes through a solution. So first, let us know what are the application of chemical effect of electric current. So first point is extraction of metals from their ore. You can take an example of iron ore. How are iron removed from their ores? They are extracted by using the chemical effect of electric current. Okay, then if we extract iron, then we need to purify them also. So it can be used for purification of metals also. Then we can create some compounds using chemical effects of electric current. It can create new compounds, and decomposition of compounds can also take place in chemical effects of electric current. Now here it is telling about a scientist who discovered the chemical effect of electric current and added a new topic to your syllabus. Okay, so he discovered electrodes. Now we are going to study what are electrodes. Okay, electrodes were immersed in water and a current was passed. They dissociate into hydrogen ions and oxygen ions. So it is saying that water are splitted up into two ions, hydrogen ions and oxygen ions. Now how? We will study that in next topic. Electrode and electrolyte. So electrode are conductor of electricity. They are conductor of electricity that can carry electric current into non-metals and other poor conductor of electricity. So they are conductor of electricity basically, and they carry the electric current into non-metals also. They pass them to non-metal also and other poor conductor of electricity. Electrolyte. So electrolyte, I already told you, they are the liquid which allow an electric current to pass through them and split them on the passage of electric current. Now that's a very important point. What does this mean? So when electricity is passed through an electrolyte, their ions, they split themselves into atoms. Okay. Now electrolysis. The production or occurrence of chemical change in an electrolyte when an electric current is passed through it. The process of electrolysis shows the following things depending on the nature of the solution and the electrode. Okay, now it is saying that the process of chemical reaction using electric current, they are called electrolysis. Okay, they are called electrolysis, and it cannot be done, this process cannot be done without these two things. Okay, they cannot be done without these two things. Okay, let me color it, change its color. Okay, so electrolysis cannot be done without electrode and electrolyte. Now that's the main activity I wanted to show you. Now we will see how a water splits up into hydrogen ions and oxygen ions. Okay, so these are electrodes. These carbon rods, they are electrodes. I hope you will understand. I am not writing this. It will be a very bad handwriting. Okay, let me write it. Electrodes. Okay, I hope you will manage. So they are electrodes. These carbon rod are electrodes. They are good conductor of electricity. So when current is conducted through water, oxygen and hydrogen bubbles are created. Okay, now what's the chemical formula for water? Tell me. Okay, let me tell you. So it is H2O. Okay, hydrogen atom and oxygen atom. Two hydrogen atom and one oxygen atom. Okay, so water is made up of two gases, hydrogen and oxygen. So it split up into hydrogen and oxygen. Okay, now what are these plus and negative sign? On the positive electrode, this is the positive electrode. Okay, showing positive sense. Oxygen bubble will be present, whereas hydrogen bubble will be present on the negative electrode. Now I will tell you why hydrogen sticks to this carbon rod and oxygen sticks to this rod, because you will study this in grade 9. You will study this in grade 9 that the valency of hydrogen is positive. Hydrogen is positive, and for oxygen it is negative. Okay, and this you will study in grade 9, so don't get confused in this. Just I am telling you for your general knowledge that hydrogen is positive, so it will stick to negative, it gets attracted to negative, and oxygen is negative, so it gets attracted towards positive. Okay, so this is the thing that it wants to say. Chemical reaction take place when an electric current passes through a conducting solution. This is the conducting solution, water. As a result, gas bubbles could form on the electrodes. Okay, so these are formed in these carbon rods. I hope now you understood how water splits up into these two ions. Okay, so that's very interesting topic. So there are two more characteristic applications, like deposits of metal on electrodes, change of color of solution depending upon the electrodes. Electrodes can be used for changing the color of solution. Okay, depending on the solution, that depends on the solution, what kind of solution are you taking. Now what are cathode and anode? So let us go to the diagram. The negative carbon rod is called cathode, and the positive carbon rod is called anode. I will write AN for this, and I will write Ca for this. Okay, so negative terminal is cathode and this is anode. Application of electrolysis. So now where electrolysis can be used? Applications of electrolysis: electroplating, purification of metal, extraction of metal from metallic ores. These two we have already studied, that electric currents, chemical reaction can be used for these two. Now what is electroplating? Wait, let me tell you. Electroplating or electrodeposition, they both are same, don't get confused. I am again saying, the process by which a layer of metal is deposited over another metal by passage of electric current. The kind of metal that is usually electroplated are gold, silver, tin, zinc, copper, chromium. So electroplating is a process by passing electric current through a solution, and there are two carbon rods of different metals. Okay, I hope there is diagram. No, there is no diagram for this. I could have shown the diagram, but there is no diagram. Let me explain you by myself. Suppose okay, let me tell you myself that electroplating can be done in two. See, this is a solution. Okay, wait, let me tell you here only. See, imagine this. These are two different metals. Okay, this is iron and this is zinc. Okay, Electroplating is a very useful process and widely used in industry. Electroplating is a technique for depositing a layer of metal with desired properties on another metal that is utilized in various industries. The main reason is as follows: to protect the metal object by coating different metal on the metal object. Cost efficient, for example, since chromium is a costly metal, the objects are made up of a cheaper metal and a chromium coating is applied for shiny appearance. Prevents metal from corrosion. Okay, so they suppose this is I have a iron can, okay, and I want it has started being rusted. So I want to add a layer of zinc. Okay, so how will I add? By using electroplating. What we will do is that in the positive terminal we will add the metal that is going to be coated on the other metal, and in the negative terminal we will keep the metal that is going to be coated on that metal. So suppose I want to coat iron with zinc, so I will keep zinc in positive terminal and iron in negative terminal. So what will happen that when electric current is passed through them, the zinc's passage will stick to the negative terminal in the iron, and a coat of zinc will be added to the iron, and iron will now suppose this is iron object. This is an iron object and it is being attacked from moisture. It is being attacked. It has started being rusted. So we will add a shield for it. We will say, don't worry, we will add a shield for you of zinc. This will protect it from getting rusted. Okay, so that's how electroplating is done. And it is saying that we use electroplating for cost efficient, that because chromium is a costly metal and we want to add chromium to the other metal, so we will use electroplating to make it cheaper. Okay, so to prevent metal from corrosion, because zinc prevents corrosion, so it can prevent iron from corrosion. Okay, now applications of electroplating. Jewelry makers electroplate silver and gold on less expensive metals. Okay, so what they do is that they keep a less expensive metal and they electroplate gold and silver to that metal. Okay. Medical equipment is made up of nickel, which is harmful to the human body. Hence, to avoid it from coming in contact with the body, a coating of platinum or gold is applied on the surface of nickel. Okay, so medical appliances are made up of nickel and they are very harmful. They are toxic for the human body, and hence we add a coating of platinum or gold. Generally people add coating of platinum because gold is very expensive. You know, tin cans used to store food are made up of iron coated with zinc. So do you know what is galvanization? I am not writing this. So galvanization is the same process to add zinc's coating using electroplating. Okay, galvanization. So here galvanization is taking place. Okay, is being placed. Thus the food is prevented from coming in contact with iron and getting spoiled. Iron is used in bridges also. To make bridges we use iron only, and automobiles to provide strength. But iron can corrode and get rusted, so we add a coating of zinc there also. This is called galvanization again. See here, over here it is written. Coating of zinc is deposited on iron to protect it from corrosion. Okay. So here it is also telling the same thing, that bridges are prevented from rust by using galvanization. Now methods of electroplating. Here now it will tell the methods. Two electrodes should be made of different metals. I told you that they were of different metals. The metal on which coating is to be done should be used as cathode, while the metal to be deposited should be made the anode. Okay, so let me make the solution again. Suppose this is zinc and this is and this is iron. Now we want to add the layer of zinc here. Okay, so we will use electroplating. Here it is written same, that this is positive terminal, this is negative terminal. Okay, the electrolyte should be solution of the metal to be coated. For example, the coating of zinc over a copper object. The copper object is used as cathode and a zinc plate as an anode and zinc sulfate as the electrolyte. So here I forgot to tell you one more important thing, that of the first metal anode, the solution must also have the same atom. Like if I am using zinc as anode, so the solution must be related to zinc. You can use zinc sulfate. Okay, so like that. The container or vessel consisting of the cathode, anode and electrolyte is called an electrolytic cell. So this whole diagram is called electrolytic cell. It contains electrolytes, cathode, anode. So this is called electrolytic cell. Now deposition of one layer of metal on the top of another metal. Now it is going to tell electroplating again. When an electric current is passed through the copper sulfate solution, copper sulfate dissociates into copper and sulfate. I told you that when electric current is passed through the electrolytes, they get split up. So it is also getting split up into two ions, copper and sulfate ion. The free copper gets drawn to the electrode connected to the negative terminal cathode of the battery and gets deposited on it. The process of electroplating takes some time to complete. So it can take time also, because it's not like that if you start pass electric current through the solution and electroplating will be done. No, not like that. So it takes time. To decrease the time taken by the process depends upon the strength of current and also on the concentration of the electrolyte. So what's the strength of the current? Is it weak or is it strong? If it's very strong, and what's the concentration of the electrolyte? It also matters. Okay, if these two helps increase the speed of electroplating. These two are the necessities, precautions that can be taken to increase the speed of electroplating. We should make sure that the electrode should be clean. The electrode must be always be clean. The electrodes used are made up of different materials. One of the electrodes is of the same metal of which the electrolyte solution is. It is telling the same thing, like that the anode was zinc and the solution was zinc sulfate. The second electrode needs to be the material on which coating takes place. Okay, so we have reached the end of the session. I hope you liked this video and it must be helpful for you for the upcoming exams. If you have any doubt, you can ask me in the comment box. I will definitely answer your question. Till then, bye bye. Have a great day. Thank you.